We'll see if this is better.
Great language to use in order to get you into the habit of doing certain things, like making sure that you have. That were in their midterm class. It's like 1 to 12. They're getting ready to transition over into their degree-specific programs, but they're doing their project and portfolio classes. They're working on a big group project together. One of the students who is he's a smart guy, but he's a little scatterbrained. He is running off and doing a lot of the work on his own, right? So he's really just trying to give it his all. He's a portfolio piece. He's really just throwing everything he has at it. And he made a bunch of code and he ran into an issue and he's like, I don't know what the problem is. And he messages his teammates. He's like, hey, can you guys take a look at my code and figure out what's going wrong and where? One of his other teammates reaches out to him and says, hey man, you didn't leave any comments. I don't know what your code is supposed to be doing. Could you go back and put in some comments? And he replies, oh geez, I totally forgot to do that. Now I need to figure out what my code was doing myself. So you leave comments in your code ahead of time, you avoid things like that happening. It's especially important when you're working with a team. Jackson HTML is a great language to use in order to get you into the habit of doing certain things, like making sure you have code that it has to be formed in a particular way and things like that. But generally speaking, HTML is a structural framework and not like a compiling language. So while I recommend you do learn HTML, it's a great skill to have, and it is useful for learning programming in general. At the end of the day, it doesn't do any conditional logic, which is kind of the biggest thing we need, right? So do learn HTML, but it's limited in what skills will be translated to other languages. Commenting, though, is a big part of HTML. So that for this particular thing that we're talking about, yes, absolutely. So here we can see a comment that is after. So you can put it on the same line after, so long as it is after that, the end of the statement. So the punctuation point, the semicolon there. So you can put it on the same line so long as like that. There is also another way to comment known as block commenting. It looks like this. You'll see this commonly in your lab. This is how to make a multi-line comment. You can also make a multi-line comment by doing those slashes on every line. It doesn't matter. Block commenting is a little bit less common because you generally don't have these big chunks of text in your files. But for your labs, you'll see it all over the place because I have a bunch of instructions in there. One of the most useful things that programming is for, that commenting is used for, and one of the most complicated things about Visual Studio is we can take a whole chunk of code, highlight it with our cursor, and then we can use a keyboard command in order to comment out a huge chunk of the code. You can do this by holding Control and pressing K, but then with Control still pressed down, hitting C. So you do Control K C. It's the only program that I've ever used that has a 2-button control command. I don't know why they do it. I absolutely hate it, but it works. So Control K C will comment out a huge chunk of code. So whatever you have highlighted, it'll comment out the whole thing. This allows you to keep that chunk of code there if you still want to come back to it. But
Voicing conjugate by 9 as agreed upon.
It's one of the very common in your files. Hey man, you didn't leave any comments, so I don't know what your code is supposed to be doing. Could you go back and put in some comments? And he replies, oh geez, I totally forgot to do that. Now I need to figure out what my code was doing myself. So you leave comments in your code ahead of time, you avoid things like that happening. It's especially important when you're working with a team. Jackson, HTML is a great language to use in order to get you into the habit of doing certain things, like making sure that you have code that it has to be formed in a particular way and things like that. But generally speaking, HTML is a structural framework and not like a compiled language. So while I recommend you do learn HTML, it's a great skill to have and it is useful for learning programming in general. At the end of the day, it doesn't do any conditional logic, which is kind of the biggest thing we need, right? So do learn HTML, but it's limited in what skills will be translated to other languages. Commenting though is a big part of HTML. So that for this particular thing that we're talking about, yes, absolutely. So here we can see a comment that is after. So you can put it on the same line after, so long as it is after that, the end of the statement. So the punctuation point, the semicolon there. You can put it on the same line so long as like that. There is also another way to comment known as block commenting. It looks like this. You will see this commonly in your labs. This is how to make a multi-line comment. You can also make a multi-line comment by doing those slashes on every line. It doesn't matter. Block commenting is a little bit less common because you generally don't have these big chunks of text in your files. But for your labs, you'll see it all over the place because I have a bunch of instructions in there. One of the most useful things that programming is for, that commenting is used for, and one of the most complicated things about Visual Studio is we can take a whole chunk of code, highlight it with our cursor, and then we can use a keyboard command in order to comment out a huge chunk of the code. You can do this by holding Control and pressing K, but then with Control still pressed down, hitting C. So you do Control KC. It's the only program that I've ever used that has a 2-button control command. I don't know why they do it. I absolutely hate it, but it works. So Control KC will comment out a huge chunk of code. So whatever you have highlighted, it'll comment out the whole thing. This allows you to keep that chunk of code there if you still want to come back to it, but eliminate it if you think that it's giving you a problem. It's one of the very common ways to debug is to comment out chunks of code that you're not sure are working, and then leaving in parts of code that you're pretty sure are working, and then gradually going back and re-adding them, right? So it's a very useful thing. If you are turning in an assignment and something doesn't work, you can just comment out the whole thing, and I can come in and I can look at it and I can give some feedback on that. Somebody's over here first.
It might also be a good way to figure out what code does what. So if you break it and find out what's broken and see how that works.
Yeah. Yeah, it allows you to go back and like execute it one thing at a time. I mean, yeah. How do you remove the comments? So you do the same thing. You highlight everything, and then you press Control K, and then U, and that'll uncomment it. So KC for comment, KU to uncomment. Useful thing. If you are turning in an assignment and something doesn't work, you can just comment out the whole thing, and I can come in, I can look at it, and then I can give you some feedback on that. Somebody's over here first.
It might also be a good way to figure out what code does what. So if you break it and find out what's broken and see how that works.
Yeah. Yeah, it allows you to go back and like execute it one thing at a time. I mean, yeah. How do you remove the comments? So you do the same thing. You highlight everything, and then you press Control K, and then U, and that'll uncomment it. So KC for comment, KU to uncomment.
Hi.
Alrighty, so this right here is known as a code block. There are many things that are known as code block, but a code block is going to be a chunk of multiple lines of code that are executed at once. This particular code block is the main method of our application. This is also known as the primary entry point of our application, which all that means is if you have a .exe file, if you have some kind of program and you open it up, all that program does is run the code in the main method. That is it. That is the main method's function. If something is not included directly in the main method one way or another, like if it's not like called in the main method and spiders out to the rest of the program, it does not exist. It does not do anything. So the main method does all the things in our program. You'll see that in function in a little bit. Generally speaking, we try to keep the main method as empty as possible. for the first few things in this class, you'll see the main method is going to be pretty crowded. We're going to just be working there exclusively. But yeah, this is a code block, and this code block is our primary entry point. So this right here is my whole application. There's nothing other than that. All this application does is says, my name is Doug, writes Doug to the console. That's it. Things here like int, return, and kind of, to a lesser extent, string, are known as keywords. These are important reserved words by the operating system. We want to think of this in the context of like in the English language. This is like the, it, there. They're all things that exist in the language already that have an important purpose, right? We cannot like interchangeably throw other things there, right? So these are always going to be this red color. String, like I said, is a weird one. They're always going to be this red color, and that also means we can't use them for other things. Like I would not name my child the. That would be a weird thing to do. And the same thing, you cannot name your variable int because it's reserved. It will not let you do that. These guys are operators. Operators will generally be in this red color in my syntax language. These again are reserved things that have special purpose. They will do things like they would do in math. Most of the operators you will see will be math operators, but there will be other operators too. For instance, this double colon and this little asterisk, or these little arrows here. These are separate operators that perform a particular operation that's not necessarily math related. We'll look at those in a bit. This guy right here, this little prefix, is known as the standard template library. Why is it STD and not STL? That's because there's another standard template library that lives inside of this. It's a weird, archaic computer science history thing. But this STD prefix is our standard template library, and this is known as a namespace. Okay, so this is a namespace. All of this means, what we're looking at literally in this code is this double colon here represents a parent-child relationship. So this says we are getting string from inside of the standard template library. So this says open up the standard template library and pull out string. Open up the standard template library and pull out cout, right? So we prefix those things that we need with the standard template library. The standard template library itself is a collection of tools that are added on top of base C++. Like I said, C++ is old and kind of archaic and very basic. And there's a lot of modern conveniences that we expect as developers in 2025 that C++ does not provide by itself. Things like strings. There are no strings in C++ verbatim. There are ways to do stuff that looks like a string in C++, but we don't have access to the string data type itself and the affordances that we would normally expect to see of a string. So we get that from the standard template library. Same thing with cout. Cout, you'll see in a second, but cout will allow us to write to the console. The tools that are provided to write to the console in C++ are very old and archaic. So we have things like cout, which allows us different affordances and modern conveniences on top of what we've already used. So we're going to be using the standard template library liberally in this class. We will use them for any kind of modern conveniences. When we need it, I'll show it to you. Jackson, those are going to be in Getting Started PG1. There's going to be a big image link to go to the Microsoft Visual Studio. You can also just Google Microsoft Visual Studio Community. That'll get you on the right landing page. White space. White space is a critically important part of programming. These are the characters in your code that you do not see. These are things like carriage returns and spaces. So this is a carriage return, that's a new line, and these are spaces, right? This indicates space. This helps keep our code organized. I will do a logical grouping of my code based on what it's doing, right? So like this is like my first part of my code where I'm initializing my variables. This is where I'm writing it to the console, and this is the end of my application. So I will generally try to like put white space in between those things just to make it easier to read. In addition to that, you'll notice all of these things are an even number of spaces inward from these two parentheses, right? You can do this by doing a single tab. This will tab space this stuff in. So if I tab in once, it'll move all these over a specific amount of spaces. And all of these things now, since they are lined up, I know belong inside of these curly brackets. If there were other curly brackets here, I would tap space this stuff in even further. So again, I can make sure that it's easier for me to visualize that these are part of that. Those rainbow brackets and rainbow indentions will also help you keep track of those things. One of the hardest things for beginner programs to do is keep track of where one set of brackets begins and another set of brackets ends. And it's a critically important skill. So do everything you can to try to keep track of that. Alrighty, so at this point, you guys should understand basic programming terminology, including variable, keyword, operator, and comment in the context of programming. You should understand how variables allow us to store and reuse, not reusable, store and reuse values throughout our application. So it stores that value, that data in memory, and then we can recall that data by referring to the variable name.
That day is
The
good.
difference between
Just
variable
taking
declaration, that is
programming.
just creating a variable, not assigning it a value. Definition, that is assigning a variable
Studying
a
that
value,
full sail.
whether that variable was previously given a value or not. And initialization, which is the combination of creating and defining a variable with values.
I don't know if you can see me.
You should
or not.
understand that std string is the data type that we use to store words or phrases comprised of
There it
multiple
is.
characters, and how the plus operator allows us to combine two or more string values, either from raw literal values or values that were previously stored in variables, to create
Nothing happened.
one
I'm
combined
studying.
string value using
I'm studying
string
programming.
concatenation.
For Fullsail University.
You should also understand that the int data type allows us to store whole number values. And
Everything that you need to know if you care is on my channel.
within their code to help
So, but I have to do my homework today.
blocks of
I don't
code
have time
for
to
testing purposes.
chat. I just have my
Finally,
homework.
you should understand how white space helps maintain human readability
Taking game programming
in code
Full
by
stop.
providing a clear
right now.
grouping. Anybody have any questions about this so far? Alrighty, we're gonna take our final break. It is 3:55. We're gonna come back here at 4:10. We're gonna get to the last bit of our code we need to talk about, which is going to be console.io, and we will hopefully have some time for a brief demonstration as well as an explanation of your lab one assignment. And before we go on our break, does anybody have any questions about any of this? Yes.
Will this, slideshow be, I don't know, what, show us back at?
These slides I don't have right now, but I can attach them to the meeting. And you will have this meeting recording in your, so you'll have access to this meeting recording in your meetings tab, and you'll have this lecture chunked up into shorter bits as part of your research. So you'll have it in a few different places.
Okay.
All right. How do we get those to show up in Visual Studio? What are you talking about specifically when you say those? How do you get the white space to show up? I don't know. The white space won't be visualized. You won't see it. I just manually added that as part of the text. There might be a way to do it, but if there is, I don't know what it is. All right. I will see you guys at 3:10. I'm gonna leave this slide up so you guys have. Alrighty. Yeah, most codes will use a code will use what's known as a monospaced font. That means every character in the font is the same width, right? So you can see that here, the P, the R, the O, they all take up the same amount of space. So this is a monospaced cursive font. Again, I would not, it works for them. But yeah, so it is specifically a script font that was designed for programming, right? Hey Charles, no problem, thanks for coming out. All right, so to review the keywords we talked about today, string, which is kind of not exactly a keyword, but basically should be expected to be a keyword, is a keyword that stores a string of characters that represent a word or a phrase. They're going to be wrapped in double quotes. We have char, which we didn't look at previously, but we've kind of already kind of already seen a bunch of times, and that's because strings are made up of individual chars. Char is short for characters, so anything that you would expect to be a single character, your ampersands, your exclamation points, your special characters, your A through Z and 0 and spaces, all of those are individual characters. Characters are stored in a single quote, so similar to how a string has a double quote, characters have a single quote here. You can see here capital A is stored in the character variable called letter. Now,
Welcome
one
to the
thing
stream.
about characters that is going to come
Doing
up
my
several
homework for
times
Fullsail
in this
University.
class is characters are a primitive data type. That is, they are a base data type unlike a string. They are like one of the core features of any programming language. And every programming language, as I said before, pretty much only deals with numbers at the end of the day. As a result of this, character values store numerical values in addition to these characters that we see here. The numerical value for A, for example, is 65. So if I assigned a value of 65 to char letter, it would still result in a character A. That's not super important for you guys to know right now, but that will come up several times in this class. You'll be dealing with integers and characters interchangeably. Then we have some of our operators here. We have our single equal sign, which is our assignment operator. We will deal with other equal signs later, but the single equal sign is going to be used only and ever for assignment. So anything on the left side of the equal sign will be copied to anything on the right side of the equal sign will be copied to the variable on the left side. And we also looked at the plus sign, which does string concatenation in addition to addition. It'll just add two things together. We also saw this guy. This is our scope resolution operator. Again, it represents a parent-child relationship. This basically just says we are trying to call something from within something else. This will almost exclusively be used for calling different things out of the standard template library namespace. We might use it for one or two other things, but more or less, this is what it's going to be used for. And we also have these two guys right here, which we're going to talk about in a minute. These are for insertion and extraction. All right. So, I'm actually just going to skip this whole last bit because we're going to jump straight into the demonstration portion of this class. Since I am doing the lectures this month, I get to do things the way that I want to do them. And the way that I typically do stuff is I do a series of projects based on a single reference, a single real-world reference. The real-world reference that I tend to choose is one that is incredibly popular. It's actually the most popular intellectual property in the entire world. Does anybody know what the most popular intellectual property in the entire world is? Tetris? Tetris is a good guess. What else we got? Only Tetris? That's all? Mickey Mouse is another really good guess. Zelda's a good guess.
Pokemon.
What? Pac-Man? The most valuable intellectual property in the entire world is comprised of 3 or 4 different mediums, right? The card game alone creates about $13 billion per year. Pokemon. The most popular intellectual property in the world is Pokemon. So, we are going to use Pokemon as our example. We are not going to use that shit-ass fucking excuse for what they're calling a $70 video game that was just released. I'm sorry, I have opinions. We are going to use the tried and true good part of Pokemon, which is going to be Pokemon Gen 1. Nothing wrong with Gen 1. A+, 10 out of 10 game. In particular, we're going to be using Pokemon Red for Game Boy as our reference. Look, I don't care that much about Pokemon. I really have not played a Pokemon. I mean, I keep trying to play Pokemon games. And they just keep giving me garbage. So like, the Pokemon that I want to play is the Pokemon part of Gen 1. I just want to catch a monster and evolve it and whatever. It was 2025. We don't have voice acting. It's absurd. I'm not giving Creatures Inc. $70 for that.
You know, like put in like only $100 into that game or something.
Yeah.
It's way less than what they do.
Alright. So, for those of you guys that are unfamiliar with Pokemon or Pokemon Red somehow, this is the example of what we're going to be doing. I'm going to do this at a higher speed here so we can get an example. So there's going to be a series of things that are happening here. There's a bit of a joke comic I'll show it to you guys ahead of time that says all games are either menus or parkour. Every game that exists is either menus or parkour. So Counter-Strike, for you guys, that's known as how do I not? It's a V. What's the V game? Valorant. Counter-Strike is Valorant. For those of you guys that are not old enough to have played Counter-Strike. So Valorant, menus, right? Apex Legends is parkour. Baldur's Gate, clearly menus. Minecraft is clearly parkour. Despite there being a lot of jumping, anybody who's played Destiny 2 can tell you Destiny 2 is menus, not parkour. So, Pokemon is nothing if not just a series of menus. So you'll see a lot of menus in this. You'll also see just a lot of general text. I hate that YouTube has been redesigned. I don't know how it works anymore. What is any of this? How do I make this full screen? Why is it like this? Yeah, that'll do it. All right, so opens up a little cutscene, shows some images on the screen, plays some music, and then we see a menu. This menu is two bits of text that we can choose from. We have new game and option, and then Professor Oak shows up and he shows some text in a formatted box, right? So we have a box here showing some text. So he's writing some text out to the screen. Hit a button to read more text, hit a button to read more text, hit a button to read more text. A lot of text. Pokemon loves their tutorials. Actually, you know what? For as many tutorials as exist in the new Pokemon, Pokemon Gen 1 has practically no tutorials. Just throwing it out there. Anyway. So, here's what a Pokemon is, blah, 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 blah. Use them to fight, he studies them, yada, 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 yada. Then, what is your name? So, prompts the user with some type of question by displaying some kind of string question to the screen. Then, the user is given a menu choice, and they have the option to write in their own name. Since they don't have a keyboard, they can't type in stuff themselves, they have some kind of visual indicator on the screen where they will enter in some type of data. That data will be stored and remembered, so every single time that the game has to refer to you, they will refer to it by referring to that data that was stored in memory, as opposed to having to ask you your name every time. So what we just saw there is they made a string variable and stored your name in it, and it'll be stored in memory. We've already learned about that. Cool. Then they refer to you by using your name, so they recall that from memory, show it on screen, and display that they know who you are. This is Professor Oak's grandson. For those of you guys that don't know, Professor Oak is the ripe old age of 60, so he cannot remember his grandson's name. So he asks you his grandson's name, you go through the same process. You store it, you write a name, you store it. He refers to his grandson by recalling that name from memory. You have both displayed on the screen. From there, the rest of this game is just going to be a series of menus and recalling values. So this is a good stopping point. This is our reference point for what we are going to try to attempt today and what will be reflected in your guys' Lab 1 assignment. So we only have about 5 minutes left. Don't worry, because we have more than enough time to get done what we need to get done for this. Step number 1, I'm going to open up Visual Studio for the first time. I'm going to go to create a new project. And in here, I'm going to have a list of available options. Right now, it's set to C++, so I can see my C++ options. I am going to make a C++ console application that prints hello world by default. I'm going to press next. Next up, I'm going to have to name my project and determine where it is going to be stored. By default, it's going to try to store yours in your user folder. I don't recommend that for a number of reasons, but it just makes things really complicated. What I do is I go to my file explorer. Come on, grab it. I go to my file explorer and I go to my C drive. On my C drive, I right click and I make a new folder and I call it something like FS. And then in here, I make a folder called PG1. Generally speaking, I'm going to be working in this archive folder. So this is the folder that I've used in the past. I've used this current folder. This is the folder that I've used in the past. I'm going to rename it 2508 because I think that was the last time I taught on campus. Sorry, 2509. Then I'm going to take that and put it in my archive folder. And I'm going to make a new folder called current. And this is where I'm going to store my projects. So it's very easy for me to find. It's not trying to sync with OneDrive, which is just going to cause nothing but problems. It's got a short and distinct file name. There we go. I'm going to name this day one pull commands. I press enter, and this is going to open up my project. So here we go. We can see my project here. This new Visual Studio update. I will do that eventually. There's all this placeholder text here. This is just trying to give me some instructions. I'm going to get rid of all that. When I create a new project, I created a C++ console application. The C++ console application that prints hello world to the console by default, which is what we see here. So this is Visual Studio. There's a few things going on here. Most of them aren't important for today, so we're not going to worry about them. But this is my C++ code. You can see we have my main method, which we previously talked about as my primary entry point to my application. Up here, we also see this line that says include IO stream. This is required for a console application because IO stream literally means input output. This allows us to output data to the console and receive user input from the console. The console is how we are going to be interacting with both of our applications here, because actually anybody, if you guys talk to anybody who's in any further degrees, you'll find that graphics are one of the most difficult things that we do in computing. So we don't have to deal with that. This right here is going to allow me to run and test my application. You should not press this play button. You should only ever press this one. When I do that, we will see hello world printed to the console. Any questions so far? Yes? Because this actually allows us to run and test. This runs it without testing it. So if something breaks, we run it with this, it'll give us feedback. If something breaks here, it'll just close. So you don't really, the one on the right is not very useful. So by default, we have this line that says std cout, these two little arrows. No, it's not Visual Studio Code. It's Visual Studio Community. Visual Studio Code is different. So Visual Studio Community Edition. Oh, I sent that to the wrong person. Visual Studio Community. All right. So here, what's literally happening is we are, from the standard template library, we are calling the cout object. We'll talk about objects later, but cout stands for character out, or otherwise console output. So this is the structure that is writing to the console. Here we have the insertion operator. It is inserting data into the data stream, which is going to send it to the console. Streaming means exactly what you think it does, right? Just like a river. Where you have a mouth of the river and it flows downward, and data goes from the top to the bottom. The output being the outlet being the console, right? So anywhere along the river, I can throw in data. I can throw something into the river, and it's going to end up at the mouth, right? It's the same thing that's happening when you're streaming from like YouTube or Twitch, right? You have somebody on one end who is sending data and is ending up on the other end. You are the other end, right? Same thing. Except the other end here is going to be the console. So we say, hello world, this is a literal string, right? You see this guy right here, this is just a string. This /n on the end is a special character that makes a new line. It's called a new line character. But what we generally are seeing is hello world written to the console. Done. Cool. I'm gonna comment this out so we can leave it here as a reference. So I'm just gonna put 2 slashes here. And I'm gonna do what we just saw. I'm gonna mimic what we saw in Pokemon, right? I could go through the process of making the whole box and stuff like that, but since we're limited in our time, I'm just gonna get right to the point. I'm gonna say std cout, and I'm gonna write my own message. I'm gonna say, hello, what is your name? Question mark. I'm gonna end this line by doing another insertion and doing std. Oh, I forgot my thing does this. Std end line. So this will end the line, which means it'll start writing on the next line. Right? That's how that works. We do this end line here. This is basically going to say we are no longer going to write. We're going to do std end line. I'm going to save this, and it's not going to work because my Visual Studio is broken for some reason. I haven't been able to figure out why. Now, what's going to actually require me to do? What it's actually going to require me to do is select my Visual Studio, and I cannot even Alt F4. I don't think. I actually need to go into my Task Manager and kill it. It's done. But when I go to my Task Manager and kill it, if I open up Visual Studio again, it's going to say, hey, we noticed that something broke last time. Do you want to open up your same thing? And we should see all that code there again. Nope, of course not. So std cout, what is your name? Question mark. And then std end line. Don't feel pressured to follow along with me right now, too, by the way. There's a follow-along video as part of the first research that will go over this same stuff. So if you guys are still installing or setting up your project or just generally lost, don't feel pressured to get this done right now. We're just running out of time, so I gotta move kind of quick. If I were to run this right now, instead of saying hello world, we will see hello, what is your name? Straightforward, yeah. Yeah, right, the line number should be here by default. If you don't see line numbers, you can go into Tools, Options, and search for line numbers. And then you can go into here, and you should see a thing that says line numbers. You really do want to have that on. Alright, next up, I want to prompt the user for their name, right? I want to be able to ask the user for their name the same way that the game did. So we're going to say std cout, and I'm going to say name : space. I'm not going to put a new line here, and I'll show you why. You see how when I'm clicking here on Visual Studio, we see this flashing line here? That's known as a cursor, this flashing line. That cursor generally indicates that I can type here, right? We see that, we know we can type here. I want to display a cursor to my user as well, so that they know they can type here. But I want it to be directly after this prompt. I don't want it to be on a new line. So as a result, I'm not going to cut this line off yet, right? Now, before I prompt the user, I want to be able to store their name because that's what I'm asking them for. So I'm asking them for their name. I do want to be able to save that name so I can recall it later on. So I'm going to make a string type variable by saying std string and creating it saying name, right? I'm going to initialize it with an empty string. So that means I'm going to put the quotes here, but I'm not going to put anything in there. It doesn't really matter what I put here because I'm just going to override it later. But I do want to initialize it with something intentionally so that it's predictable later on. Remember, we talked about that earlier. So now I have a variable called name, and I'm asking the user for their name. I'm actually going to take this and move it to the top of my main method, because I generally like to keep all of the variables that I'm going to use up here so I can see a clear and easy list of the things that I'm going to use later on. Now I'm going to get from that from the console. So we've written to the console using cout. We're going to get from the console in order to receive that user feedback. The way I'm going to do that is a few different ways. I'm going to recommend you guys use getLine. Now by default, getLine isn't going to work because it's part of the string tools. So I actually need to come up here and I need to, in addition to IOStream, include string. It's still not going to look like it's working, and it won't until I finish it. But I do need to have string up there for that to work. So now that I have that, in here I need to put two things. So inside of these parentheses, I need to put two things. The first thing is the only thing I'll ever put, which is stdc in. stdc out means writing to the console, right? Outputting to the console. stdc in will be taking input from the console. So we're gonna be capturing user input from the console and doing something with it. Any questions about that so far? Cool. And I'm gonna comma separate here, and then I need to put the variable that I'm going to store the value that I extract from the console, and that's gonna be name. So when I do that, my little red squiggly line goes away, everything looks correctly. So what we're gonna do is we're gonna say, hello, what is your name? We're gonna ask them for their name. This is gonna pause the console and wait for input. So we're gonna see a flashing cursor. They're gonna type in their name and press enter, which is done by this. When they have pressed enter, their data is gonna be extracted from the console, stored in the name variable, and then we're gonna say stdc out, welcome, comma, and then we're gonna concatenate in their name into the middle of this, and then concatenate in an exclamation point at the end, right? So we talked about concatenation before. It's gonna combine several strings. In this case, it's gonna combine string welcome, that's a literal string. It's gonna combine the variables, the value stored in the name variable, which is a string variable, and then it's gonna combine it with an exclamation point at the end to make one full string that says welcome and whatever they enter in as the name. Any questions about this so far? Yeah. Yes, so the getLine function uses stdc in. stdc in will pause the console and wait for user input. So.
Whenever I try to go back and type something in, it replaces.
Yes, it's because you have the insert key pressed. The insert key is really easy to press on this keyboard because it's next to your arrow key. It's also above your backspace, but you accidentally hit it on your next to your arrow.
I haven't been pressing it or any of the arrows.
You might have that thing.
So it's,
Insert, oh, it's not as different on you guys. Yeah. You might have that figured out on top, but it's above your backspace key. Yeah, on mine, you guys have a different laptop then. On mine, my insert key is next to my arrow key, so I always hit it and forget. Christopher, if you're doing the follow-along videos, there's a project provided for you. For the labs, there's a project provided for you. For lab 1, you guys are creating your own project. So lab 1's the only time you're not gonna use a pre-created project. All right, so let's run this. Give it a go. So I hit the run button up there. You can see here we see hello, what is your name, and we see the flashing cursor. Flashing cursor indicates to the user that we are waiting for them to enter in some type of data. I'm going to type in Doug, and I'm going to press enter, and it says, welcome Doug. We have now written data to the console, read data from the console, and stored data in a variable. That is the only thing you guys are required to do for your assignment today. Lab 1 actually has you do this twice. Lab 1 will have you ask them their name and their age and write those to the console. So you're half done with Lab 1 if you've gotten to this point already. Anybody have any questions about this? Yeah. Do you have include string at the top? Do you have stdc in? It must be written exactly as it's shown. You're going to see a red squiggly line. What does it say? So your name variable is not the name variable real quick. It says identifier name is undefined. You do not have a variable called name available to you right now. Any other questions about this? Yes. So this is a weird thing. This happens sometimes in Visual Studio. Press L because it's not really run it. Go to the build menu. on your taskbar block. Open up your task manager. You're going to find the application called console application. It's going to get a background process. So it's still running even though we don't see it. So it's right there. It might be there twice. Yeah. So close both of those. Reopen Visual Studio and it'll fix it. That's it. If you have to do like a weird specific accidental thing where you close Visual Studio but don't close the project, and it looks like you closed the project, but it leaves it open, and it just kind of remains hanging around there. So I'm glad you ran into that now because other people will run into that problem. If you are not comfortable with the Task Manager, just reach out to Peter, we'll fix it. Christopher, every single time you open a project, you will open it using the solution file. The solution file opens up the entire project. If you open up an individual CPP, you don't get the entire project. And the project is usually comprised of multiple files and libraries and stuff like that. So you have to open it using the CPP, or using the solution, in order to get everything that's required, other than just the one text file. Kiera, the difference between Visual Studio and Visual Studio Code is Visual Studio is a full-featured IDE. It has the compiler and the debugger and everything in it. Visual Studio Code is literally just a fancy text editor. You can add other components on top of it, but you have to do that manually. So it's very lightweight and allows you for more customization, but you have to set up every single part of it yourself. So as a result, we give you Visual Studio Community, which is already done for you, which is much easier to use. How you guys doing? Yeah. And you have get line in there correctly? I'll come over and look at it. If you guys don't have any other questions, I'm going to wrap up this lecture online. I'm going to continue helping you guys on campus. So but you guys online, we're not going to talk about anything new. I'm not going to close out the lecture yet, but I will have to close it out soon. But we are going to wrap up the recording so that the recording starts getting uploaded. The recording will be available roughly 2 to 3 hours from now. So keep an eye out on that for FSO. But thank you guys all for coming out. I truly appreciate everybody who makes the time to spend their time here with us in the middle of their day. I know it's a big commitment to be here, but you're doing the right thing. You're setting yourself up for success. So thank you all for coming out, and I will see you all later. There we go. And we will transition over to our poll. I'll wait for some people to get in there. Go. So what is the best gaming franchise of all time? This is not the biggest one, just the best one, in your opinion. These are all opinionated polls, but there are some wrong answers. Kirby, that's a choice. I mean, that's fine. I'm not. Kirby's got consistency for sure. Halo's really a choice, man. As much as I like Halo games, like some of those Halo games are just fine. Just fine. clarity, Activision and Ubisoft are publishers. They're not, and developers to a degree, but they're not franchises. Helldivers is good, but they got 2 games in there. I think it's a little premature for us to say Helldivers is the best franchise of all time. Personally. Overwatch. I was just talking to my friends about this yesterday. Like, first of all, imagine playing Overwatch in 2025. Like, who among you is still resilient enough for that? Because I'm not. But also, man, I just want more games that are Overwatch, but not Overwatch. Like they spent so much time making all these characters that have all this story and all this lore, and we just like threw it away. Like, where is my friend swap, 4-person co-op Overwatch payday style game? Right? That's what I was sold with Overwatch 2, and I never got it. And I would take. So here's an aside. There's a book called Play Nice, Play Fair: The Rise and Fall of Blizzard Entertainment by Jason Schreier. If you can't read like me, because I cannot read at all, but you do have Spotify Premium, you can get the book on tape. It's an audiobook. But during that book, one of the things he talks about is the acquisition from Microsoft, right? And the reason Microsoft is buying up all these companies is so they can increase the value of Xbox Game Pass. We already saw Xbox Game Pass nearly double in price, right? But the idea is, right, since the games don't have to be sold for $60, since they can be created with the idea that they're just increasing the value of Xbox Game Pass, Microsoft is more willing to take risks because the games don't have to sell. That's why we got stuff like the Age of Mythologies remake and Age of Empires 4 and the Elder Scrolls Oblivion remake. Those are games that like they probably wouldn't have made without Xbox Game Pass, but we get them now. So by purchasing Blizzard, we could see something like StarCraft 3, or we could see something like another Overwatch game. Like those are things that could possibly happen because of Xbox Game Pass. So I'm hoping that something like that does happen, but we'll see. So for me, in this particular question, the best franchise of all time is probably Mario or Zelda. They both have really good staying power. Like there is somewhat like Mario as a franchise, right? We have to say like all the Mario games, and like sure there's like Mario games that are not that good, but most of them are pretty consistent. And there's not a single title that has a Zelda attached to it without being on a Philips CDI that is anything that would be close to considered mid. Personally, I'm a little exhausted of the standard formula, so I was kind of happy to see Breath of the Wild, but I was not as happy to see Breath of the Wild a second time. But yeah, I think Mario or Zelda is up there. Kirby is not one that I see often, but it is arguable that it is up there. Like I said, I don't know if it's the best of all time, but it's definitely one of the stronger franchises. And honestly, I think Halo is one of the stronger franchises. I really enjoyed Halo Infinite, and I know not everybody did, but I really had a good time with it. I just think it ended abruptly, and I think they can pull it off. I think they can. I did watch the show. I had mixed feelings about it right up until the point where they landed on the Halo, and I was like, this is finally where we're gonna get good, and then it got canceled. Like that was the part I wanted to see, right? Like season 3 is the part of the show that I wanted. I didn't enjoy, like there's some really questionable stuff going on in that show, but if you forget that Halo existed before that show, it was fine. I don't know why we had this whole side story with the girl, the girl, the human girl from the planet. Like she's in that show way too much. The one that he lets stay with a friend on. Yeah, the one that stays with I forget his name, but yes. But yeah, like I said, these are not bad, except for the ones that are studios not franchises, but it's okay. Not holding anybody, not holding that against anybody. But all right, so next up, what, if anything, from the previous lecture would you like me to review today? As a reminder, we're now on our second lecture that we're on Wednesday, right? So if we're going by our previous, the outline, the schedule, the calendar that I set up, right? By this point, you should have your software. You would ideally, right, have your software installed. You would ideally have a solid to, pretty firm understanding of how to store data in variables, in particular whole number values as integer variables and strings as words and phrases. You would also have a solid understanding of how to write to the console and read from the console, right? So that was the whole goal yesterday. At this point, you should have hopefully started your lab one. Ideally have completed your lab one, but if you're still working on your lab one, that's fine. If you have not started on your lab one, or if you've not yet completed your lab one, I would recommend going through the 401 video on FSO. I did a demonstration of everything that you need to do that, as well as the demonstration at the end of Monday's lecture, which will be on the meetings tab on FSO, because I give you the first, you have to do the same thing twice in lab one, and I did the first half of it, so you just need to do that again, and you're pretty good. All right, wait, got one. Yeah, you really do want to have your software installed today, minimally, because today things are gonna obviously ramp up at least a little bit. Give me a second here. I'm gonna open up. Wow. Open up Visual Studio Code. So loud. I'm not going to review everything. If you need a review of everything, then maybe you should watch videos on episode. But I can go over declare, define, and confused in lab 2. Christopher, we are going to talk about that today. That is today's lecture. So all the stuff that is required for lab 2, we're gonna talk about here. Let me fix my volumes here. Hold on. I'm going to blow everybody's ears out for a second. We are way too many volumes. We're going to hang right in this area. I'm going to allow people to keep typing, and while you do that, I am going to pull this up real quick. So this is Visual Studio Code. I talked about this a little bit previously. But Visual Studio Code is effectively just a fancy text editor, right? Whereas Visual Studio is a whole suite. Visual Studio Code is just I can type stuff in here, and I say I want it to be syntax highlighted as a particular thing, and it'll do that for me. So it'll pick anything. It cannot run my code. If I wanted to be able to run C++ code, I'd need to install a bunch of tools on top of that. I don't want to do that. I just want this to be a fancy text editor that'll make stuff look good without me having to create a whole project. So we were talking about variable, define, declare, initialize. So let's do, we'll do integers because that way I don't have to use standard template library. So we have int number here. So this is a variable declaration, right? This is a variable that has been created. It exists. It lives here. Does not have a value, right? So there's no value assigned to this variable, but it does exist. This will be by default with our compiler. So a specific version of the compiler that we're using with a specific version of Visual Studio that we have right now, yada, 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 will be initialized with a number that's something like -8 million or something, like, I don't remember. But generally speaking, we want to avoid this, right? We don't want to do this in particular because this could lead to errors, right? It could, because if we try to use this variable, but we don't have a value assigned to it, it's just going to break out, right? And that's why the compiler initializes it by default in secret. But this number is not much better, right? This is some kind of randomized value that doesn't have much of a meaning to us. So it's generally a better idea to give this a value that makes sense. This is defining the variable. This is assigning a value, right? And we can do this, we can either do it like this, or if the variable has already been given a value, like if it was initialized or something like that, we can come here and we can say number is equal to 10. And this is redefining, right? So this is taking a value and overriding the existing value that was in there. So there was a value in there, there's a different value in there now. So what was once negative, 8 million is now 5, is now 10. When we define a variable, that is, when we give a variable that already exists a value, we do not put the data type, because it already knows what it is. If we try to do this, we're going to get an error that says we're trying to create another variable where that variable already exists. So it's not going to let us do that. And then finally, we have initialize, which is a combination of both of them. All right, so initialize is we're creating the variable and we're assigning a value from the get-go, which is ideally how you create your variables, right? Like I said, it's going to initialize your variables either way, but it's better to do it intentionally with values that we understand, the predictable values. This is now 10. I say I want it to be syntax highlighted as a particular. No new questions? All right. So we will end up going over everything again just by the nature of what we're teaching, because I am doing console I/O for the majority of my demonstrations, but I'm not going to do all of it like right now because it's just going to have to come naturally. All right. So I'm going to leave this here. And today we're going to talk about two different topics. Number one, we're going to talk about debugging our code, how to find errors, how to identify errors. And number two, we're going to talk a lot about we see this, we're like, okay, the variable's been set up correctly, and we know variables either way, finding, right? So this is taking a value and we do not put this, like if we're just looking at code like that. So it's have a value, something like stuff look good without me having to create a whole project. So we were talking about variable define, declare, initialize. So we'll do integers because that way I don't use standard time. So we have int number here. So this is a variable declaration, right? This is a variable that has been created. It exists. It lives here. Does not have a value, right? So there's no value assigned to this variable, but it does exist. This will be by default with our compiler. So a specific version of the compiler that we're using with a specific version of Visual Studio that we have right now, yada, yada, yada. It will be initialized with a number that's something like -8 million or something, like, I don't remember. But generally speaking, we want to avoid this, right? We don't want to do this in particular because this could lead to errors, right? It could, because if we try to use this variable, but we don't have a value assigned to it, it's just going to break out, right? And that's why the compiler initializes it by default in secret. But this number is not much better, right? This is some kind of randomized value that doesn't have much of a meaning to us. So it's generally a better idea to give this a value that makes sense. This is defining the variable. This is assigning a value, right? And we can do this, we can either do it like this, or if the variable has already been a value assigned to it, it's just going to break out, right? And that's why the compiler initializes it by default in secret. But this number is not much better, right? This is some kind of randomized value that doesn't have much of a meaning to us. So it's generally a better idea to give this a value that makes sense. This is defining the variable. This is assigning a value, right? And we can do this we can either do it like this, or if the variable has already been given a value, like if it was initialized or something like that, we can come here and we can say number is equal to 10. And this is redefining, right? So this is taking a value and overriding the existing value that was in there. So there was a value in there, there's a different value in there now. So what was once negative, 8 million is now 5, is now 10. When we define a variable, that is, when we give a variable that already exists a value, we do not put the data type because it already knows what it is. If we try to do this, we're going to get an error that says we're trying to create another variable where that variable already exists. So it's not going to let us do that. And then finally, we have initialize, which is a combination of both of them. All right, initialize is we're creating the variable and we're assigning a value from the get-go, which is ideally how you create your variables, right? Like I said, it's going to initialize your variables either way. But it's better to do it intentionally with values that we understand and predictable values so that we keep our code, something that we understand at a quick glance. Because when we look at our code and we see something like this, like if we're just looking at code, just raw code, right? We're looking at something like this, we don't know inherently what version of the compiler we're using and yada yada. We just know we're looking at some kind of code that appears to be C++. And the first thing we see is this, then this indicates immediately a potential problem, right? But if we see this, we're like, okay, the variable's been set up correctly, and we know that it's not going to try to be accessed without having a value, right? So anything that we can do to make our code human readable at first glance without having to debug it and stuff like that, that's going to be our best bet. Does that make sense? Did anybody have a question about that? All right, let's check back over to Chrome real quick. No new questions? All right. So we will end up going over everything again just by the nature of what we're teaching, because I am doing console I/O for the majority of my demonstrations, but I'm not going to do all of it right now because it's just going to have to come naturally. All right. So I'm going to leave this here. And today we're going to talk about two different topics. Number one, we're going to talk about debugging our code, how to find errors, how to identify errors. And number two, we're going to talk a lot about numbers. So let's get into the first half. We're talking about our debugger. Debugging, we're not going to have the full conversation today because debugging is going to be a larger conversation, and it's really going to be a skill you guys are going to have to develop on your own over time. The reason I say that is because I cannot possibly teach you every single issue that you're going to run into, but I can teach you some techniques to overcome issues as you encounter them. This is not lecture 2, this is lecture 1. There we go. I'm going to turn this down a little bit, but I am going to leave the volume of my... Where's the rest of this lecture? Why's the whole first bit of this gone? Hold on, somebody messed up my lectures. Carl, what have you done? Somebody deleted my first few slides, and that's fine. I can deal with that. Christopher, I have no clue what that is. I've never seen that in my life. I would have to Google that. Let me see if, let me see if I can't figure out just real quick, where the rest of this lecture went. Because and deleted my first few slides on accident. Not pointing fingers at anybody, but if I can't find them, then it's fine. We can roll with it. But if I can find those first few slides, that would be ideal. Can I see like a version history? I know Google lets you do that, Microsoft, so certainly you should, right? Right? Wow, this internet is just the slowest it's been in my entire life. Yeah, please just go to my OneDrive. Why? Thank you. Opening up your email and it goes into light mode first for some unknown reason, flashbangs you. Love to see it. Was last modified August 6th. Yeah. I imagine there is probably a way for me to revert the changes that were done to this thing. I do not have them right now. So we're just gonna have to run with it. And I will figure that out. Oh, wait, version history. I found it. Gasp, it was me. I deleted the first few slides. It wasn't Carl. I don't know why I would have done that, but we're gonna fix it. It's fixed. Alright. So, while that's doing that, I'm just gonna get started. So this right here, by the way, since Microsoft Visual Studio Code does not have all those fancy tools associated with it, it's not going to do debugging and error handling out of the box, right? So where we would normally see stuff in Visual Studio, I'm not going to see it here. Again, this is just a text editor. For example, this would give me an error. This would give me an error saying I'm trying to remake a variable that already exists. All right, cool, perfect. Got it. Actually, no. Wait, I hit the wrong share. Trying to present. All right. So, yada yada yada. Like I said before, by now you should understand all these things. We already had that discussion, so we can move on to errors in debugging. So, there are 3 different types of errors you guys are going to encounter, right? So the 3 different types of errors you're going to encounter are going to span everything that we are going to talk about. They are going to be varying in difficulty to identify and understand. Syntax errors are going to be the easiest to identify and understand. Syntax errors are going to be syntactical errors in your code. For example, right, when we are writing a sentence in a language, we'll use English as the biggest example because I imagine most of you guys know English, at least to a degree. But there's a proper way to write a sentence in English as far as capitalization and structure certain words that go in certain ways and stuff like that. That is the English language syntax. Sentences begin with a capital letter, they end with a punctuation point. Sometimes they have punctuation in the middle, things like that, right? That is a syntax. That is syntax, right? If we were to, for example, not start the first letter in a sentence with a capital letter, or we were to use a weird comma in the middle of our sentence in a place where it doesn't make sense, those would be syntax errors. Those are errors in the written language. Just in that particular case, the written language is English, right? This is going to be the same exact thing in code. There will be errors in how the language is written. The only difference is we are not the ones that are reading it, the computer is the one that reads it. The computer has to be given the instructions in a particular way for it to be able to understand, right? So if we see a syntax error, that's what it means. It means something that we wrote is not written correctly, and as a result, the computer can't read it, and if the computer can't read it, it cannot do anything with it, right? So it cannot run it, it cannot compile it. Some of you guys have already seen, or may have already seen, an error when you try to run your application that pops up a message that has a yes or no thing in it, right? Some of you may have even read that message. But what that error says is it says your code currently contains errors and cannot be compiled. Do you want to attempt to run a previous version of your code, right? So that means that the current code, the code you are looking at in your IDE, does not work. If you try to run it, it cannot be run. You may have an existing version of your application that was compiled previously that does work. Do you want to run that instead? So when you see that error and you hit yes, if something pops up, it's not your code, but code that worked previously. Any questions about any of this so far? All right. So, these are how syntax errors will show up in your IDE. In particular, this is C#, this is not C++, because I haven't changed these slides. But the errors are going to be similar, if not exactly the same, and the way they display will be exactly the same. So here we see 3 different types of syntax errors, right? All of these, we can identify them by mousing over this red squiggly line. So just like any other text editor, right, if I was going to open up Microsoft Word and I had a syntax error, it would probably show it with a red squiggly line. We see the red squiggly line here as well. So the first one here, we're missing a semicolon, right? Typically, this is either going to show up immediately following the line missing the semicolon or on the next line. So it could show up here, because what it's going to do is it's going to try to write this line, and it's going to get to this point, and it's going to be like, this seems different. There's no semicolon between here and there. So if it can determine it here, it's going to determine it here. If it can determine it here, it's going to be here. And that's something you guys are going to need to learn to look out for, right? There's going to be things where you're going to see errors that are doing their best to tell you where they think the error is, or the first place they can identify it, right? So, for example, if you are missing a curly brace, sometimes the computer is going to think that everything is fine, and eventually it's going to get to a point where it says, hey, wait, I'm missing a curly brace at the end. Not because you're actually missing a curly brace at the end, but because you're missing a curly brace well before that. You'll also see sometimes, like, you'll do one small thing and you'll bring up like 40 different errors. Not all of those errors are relevant, but the one thing that you did, right, is the reason that you have all those errors. So you should go back to before you see any of those errors and check those lines. So again, these are just some patterns that you guys are going to need to learn to recognize on your own as you encounter them. I can tell them to you all day, and you may recall them when you encounter them, but more likely it's going to require you guys to actually get in there and see it and feel it. So this one right here, it says the name doesn't exist in the current context. You will see something along the lines of this, or no variable has been defined of this type, or whatever. Something like that, something along those lines. This basically means the variable doesn't exist, right? It'll say it hasn't been declared, or hasn't been defined, or it doesn't exist in this current context. Something along those lines. which basically just means you're trying to use this variable and the variable has not been created yet. Or has not been created yet, or it has been created somewhere else, but it cannot be used here. And that's something we'll run into a lot during week 2, because we're gonna have to start building other code structures. But week 1, you probably won't see it too much. And then down here, the last one we see, cannot implicitly convert a string to an int. Now this is the this is the C# version of this error. The C++ version of the error will be similar. It will be a little bit more complicated and difficult to read, but you will see this thing of cannot convert to type, right? What that means is we are trying to send a value into a variable that has a specific type defined, and they are incompatible. What you will find with the C++ compiler is it's a little bit more forgiving than most compilers. This is the one we're using. It's a little bit more forgiving, and this error doesn't pop you guys to actually get in there and see it and feel it. So this one right here, it says the name doesn't exist in the current context. You will see something along the lines of this, or no variable has been defined of this type, or whatever. Something like that, something along those lines. This basically means the variable doesn't exist, right? It'll say it hasn't been declared, or hasn't been defined, or it doesn't exist in this current context. Something along those lines, which basically just means you're trying to use this variable, and the variable has not been created yet. Or has not been created yet, or it has been created somewhere else, but it cannot be used here. And that's something we'll run into a lot during week 2, because we're going to have to start building other code structures. But week 1, you probably won't see it too much. And then down here, the last one we see, cannot implicitly convert a string to an int. Now this is the C++, this is the C# version. This error. The C++ version of the error will be similar. It will be a little bit more complicated and difficult to read, but you will see this thing of cannot convert to type, right? What that means is we are trying to send a value into a variable that has a specific type defined. And they are incompatible. So if it can determine it here, it's going to determine it here. If it can determine it here, it's going to be here. And that's something you guys are going to need to learn to look out for, right? There's going to be things where you're going to see errors that are doing their best to tell you where they think the error is, or the first place they can identify it, right? So, for example, if you are missing a curly brace, sometimes the computer is going to think that everything is fine, and eventually it's going to get to a point where it says, hey, wait, I'm missing a curly brace at the end. Not because you're actually missing a curly brace at the end, but because you're missing a curly brace well before that. You'll also see sometimes, like, you'll do one small thing and you'll bring up like 40 different errors. Not all of those errors are relevant, but the one thing that you did, right, is the reason that you have all those errors. So you should go back to before you see any of those errors and check those lines. So again, these are just some patterns that you guys are going to need to learn to recognize on your own as you encounter them. I can tell them to you all day, and you may recall them when you encounter them, but more likely it's going to require you guys to actually get in there and see it and feel it. So this one right here, it says the name does. Exists in the current context, you will see something along the lines of this or no variable has been defined of this type or whatever. So something like that, something along those lines. This basically means the variable doesn't exist, right? It'll say it hasn't been declared or hasn't been defined. Or doesn't exist in this current context, something along those lines, which basically just means trying to use this variable, and the variable has not been created yet. Or has not been created yet, or it has been created somewhere. Or else, but it cannot be used here. And that's something we'll run into a lot during week 2, because we're going to have to start building code structures. But week 1, you probably won't see it too much. And then down here, the last one we see, cannot implicitly convert a string to an int. Now this is the C++, this is the C# version of this error. The C++ version of the error will be similar. It will be a little bit more complicated and difficult to read, but you will see this thing of cannot convert to type. Right? What that means is we are trying to send a value into a variable that has a specific type defined, and they are incomplete. And the variable has not been created yet. Or has not been created yet, or it has been created somewhere else, but it cannot be used here. And that's something we'll run into a lot during week 2, because we're going to have to start building other code structures. But week 1, you probably won't see it too much. And then down here, the last one we see, cannot implicitly convert a string to an int. Now this is the this is the C# version of this error. The C++ version of the error will be similar. It will be a little bit more complicated and difficult to read, but you will see this thing of cannot convert to type, right? What that means is we are trying to send a value into a variable that has a specific error will be similar. It will be a little bit more complicated and difficult to read, but you will see this thing of cannot convert to type, right? What that means is we are trying to send a value into
Trying to send a value into a variable that has a type defined.
a variable that has a specific type defined, they are incompatible.
And they are okay. Type value. description of what kind of data something holds. So is the maybe I should start calling it a data type. So I can start calling a data type. So a void is a thing. Yes, that's a good place to start. That's what it is. Object type. But how can an object? The integer is a variable. Void is also a type, but it's not an object. But it's a non-object type, meaning no value. So they're actually. So is it really? I'm gonna just use C++ type.
little bit more forgiving than most compilers. This is the one we're using. It's a little bit more forgiving, and this error doesn't pop up nearly as much as it should, but you will likely see a similar thing to this error when we get into week 3. So implicitly convert means if I have 2 values that are similar enough to where it can take one and just turn it into the other one, that's what an implicit conversion is, and we'll talk about it later on. But a string and an integer are just so different. It says, I don't know, man, I'm not sure what you're trying to do. And you'll see that kind of verbiage repeated, where it's like, it doesn't assume you're doing something wrong. It assumes that it doesn't understand what you're trying to do. So keep that in mind. These are some more examples of syntax errors, just some other things like we're trying to redefine a variable that already exists. We have another thing that doesn't exist in the current context because we have a typo. This one where it says an unassigned local variable, that means it doesn't have a value. We won't be able to run into that one. Like I said, it's going to initialize a value. It's going to initialize a local variable for you, just because that's what this compiler does now. But this right here, this is what I really want to focus on. Is let me get my pen. This green squiggly line, right? So you will sometimes see indicators in your code that show up in different ways that are not red squiggly lines, right? Sometimes they'll show up as green squiggly lines. Sometimes they'll show up as blue squiggly lines. Sometimes they'll show up as like dotted gray lines. All of those are suggestions, right? Those are things where the IDE is looking at your code and saying, hey, this looks a little weird. I don't know if you want to do this, but that doesn't necessarily mean you need to fix it. So it'll also show up in your bottom panel as a warning, right? So it'll look like this at the bottom. So it won't be an error, which will be like this. It'll be like a red, like you have an error. So this is a warning. This is an error, right? Warnings, for the most part, if you don't understand what they mean, you can ignore them. I ignored this warning here because I knew what I was doing, right? But they're just a suggestion. We call them linting suggestions, where they just go through and they try to check what we're doing on our code and try to make it look maybe a little better. There's going to be warnings, or not going to be, but there could potentially be warnings in this class, depending on how you are writing your code, that will tell you to do stuff that you cannot do. Don't do those things. If you don't understand what the warning says, don't blindly trust it. That's true for everything, right? That is true for anything you read on Google. That is true for anything that IntelliSense, which is the thing that tries to help you type stuff out, tries to tell you. If you don't understand it, don't put it in your code. And that is true for the warnings as well. In this particular case, what the warning is telling me is I've created a variable without assigning it a value. Remember I said that not initializing variables is bad practice, and that could run to errors later on? That's exactly what this is telling me right now. I can ignore that. It's not a big deal. The second type of error that we are going to encounter is known as a runtime error. As this would suggest, this error happens while your application is running. This means all of your code is good, right? It's syntactically correct, but during the execution of your application, something went wrong that caused the application to error out, right? So if the code is good and you encountered a runtime error, it's typically one of two things. Number one, it is an external source of some sort, right? Like I am trying to collect data from the internet, and halfway through the connection, I lose connection to the internet and I don't get all the data. That would cause a runtime error. I am trying to read from a file, and the file is not complete, so I don't get all the data from the file. So halfway through reading the file, I don't get all the data I'm expecting, and I get a runtime error, right? This happens all the time with DLLs. You'll see stuff like this. Error in Microsoft that says like, oh, we're trying to run it and something happened on our application, right? And the reason that happened is because those applications, whether it be a video game or a piece of software, are importing external libraries. Like for example, let's say you are trying to play Borderlands 4, it just came out. Borderlands 4 was created with minimum requirements saying you need to have this particular video card in order to play it. The video card has specific drivers from NVIDIA that provide the game access to certain tools that the video card has, right? So they exposes those tools through the drivers. So if you have the right video card, but your drivers aren't up to date, it might not have those tools. Borderlands loads up, everything's going well, it tries to access a particular tool, and you either have the wrong version or the tool doesn't exist, then Borderlands crashes saying that there's some kind of error. Same thing could happen like if you have a shader cache issue, right? It takes all the existing textures, loads them into a file, stores them on your hard drive. Something happens to those files, they get deleted or they get corrupted. You're going to run an issue with the shader cache, right? So runtime errors are usually from an external source. The alternative, the other thing it can be, is it can be an error with a collection. So a collection we'll talk about during week 2, but it is a different data structure that can hold multiple of a single type. So whereas we're storing one value in a integer variable, a collection can store multiple values in an integer type collection, right? So those are created at runtime, so while the application is running. So if something happens while the application is running, that the collection is, otherwise not what you expect or unavailable, you'll hit a runtime error. So as a result of this, though, usually runtime errors can be caught, which means that there are structures in place in order to prevent runtime errors from happening. We will not discuss them here. You will not get that type of error handling in this class. You won't get that kind of error handling for some time, but that will come in the future. So in this class, context right now, if you run into a runtime error, that is, your application crashes while it's running, it's a problem with your collections. So remember that. The last type of error that you guys will encounter is known as a logic error. This type of error sucks. This is the worst one out there. This means that your code is good, your application never crashes, but you don't get the output you expected. This means your problem solving is flawed. The thing that you have tried to code is not working the way that you think it's supposed to work. There are no error messages for this. There's no indicator that something is wrong other than when it gets to the end, it's not what you expect. As a result of this, you have to find that error on your own. So, kind of sucks, but luckily, we have tools in order to help us figure that out. Those tools are the Visual Studio Debugger. So before we talk about the debugger, a little bit of history. Back in the day, computers were created. You made programs for computers by punching numbers into a card. Numbers themselves are what's important here, right? When we talk about things that are digital, right, versus analog, the digital part, the digit refers to, it uses numbers to do things, right? As opposed to something else. So you would punch numbers in these cards. Certain patterns of these numbers would represent certain syntax of programming, and then you would feed that card into a card reader. And when you flipped it into a card reader, it would flip a particular amount of switches. Those switches would flip other switches, and as a result, you would get some kind of output. Spoiler alert, this is how computers still work today. You just give it numbers and it flips a bunch of switches back and forth. But in this case, the switches weren't like super, super small. So one day, some developers were doing their thing. Some researchers were punching cards, feeding them into a machine. And when they went to feed it into the machine, along came a moth. And the moth somehow got fed into the machine. And when the moth got fed into the machine couldn't flip switches, and they were getting errors. Now, they were unaware of this at the time, so they kept trying to feed in cards, thinking that there's a problem with their code, and they would keep getting out incorrect output. Over and over and over they tried, over and over and over it failed, until at one point, this absolute unit, this is Admiral Grace Hopper, stands up from her console, walks over to the computer. This computer is quite large. Steps inside, rifles around in the relays, and is able to identify the bug. She turns to her coworkers after pulling them off out of the relay and says, "I have successfully debugged the machine." This is not the computer that Grace Harper took the bug out of, but this is the Harvard Mark II. She actually pulled it out of the Harvard Mark I, so very similar. And you can see the absolute scale of this thing. And this is the bug. So relay number 70, panel F, moth in the relay. First actual case of a bug being found. This was written by Grace Hopper herself. So, debugging is the term that we use for removing bugs from machines. Now, to be totally fair, bugs, the term bug, to explain errors in some kind of mechanism, was used prior to computers. So it was used for, like, Thomas Edison was credited as using it before computers existed. But however, when we thought about it in the sense of a computer, it was literally referring to bugs, and now we just use that term. Now, in order to identify bugs in our code, the best tool we have is a breakpoint. So a breakpoint is a structure that we can use. Well, it's not really a structure. It's a tool that we can use as this built into part of our IDE that will allow us to put a point in our application where it pauses and allows us to observe the current state. I'm going to say this word state a lot, and that just means at this particular point of our application, what do we have available? What are the variables we have? What are their values, right? Because that's going to tell us a lot about where we are in our application. It's going to tell us, are the values what we expect? Do we have all the variables that we expect to have access to? Do they look the way that we should? If we go to the next breakpoint, if we continue through the state of the application, are things transforming in the way that we expect? Which means, are things changing in the way that we think that they're changing, so that we have a better idea of how our application is working step by step effectively. You can place a breakpoint in your code by clicking on this little left side panel. We'll look at it when we actually get into the IDE. But you'll see there's a left side panel that's kind of a different color, gray or white, than the rest of your application. And if you mouse over it, you'll see little dots show up. And if you click on a dot in a place, you can place a breakpoint there. When the breakpoint is hit, you're going to see this arrow on it. So you'll run your application will run until it gets to that breakpoint. When it gets there, it'll stop. And you should see a little panel show up at the bottom of your screen. That panel will show you the state of your application, which will allow you to start trying to figure out what's going on. The panel will look like this. So in this particular application, we are paused at this breakpoint on line 197. And at line 197, we have access to these variables, right? So these are the names of the variables, these are identifiers. These are the types of the variables. And these are the values that are being stored in those variables. This variable right here, this one, also has this error, which means there are different values stored under this variable. So this can happen with collections or more complex data types, where you can have more than one value stored under a single variable. So if we were to collapse that, or if we were to expand that rather, we'd be able to see all of those different data types. Christopher, if you are not hitting your breakpoint, typically that means that you are either the breakpoint is not in a place where the application gets to, so the application ends before it gets there, or your application is has some kind of conditional statement, right? So for example, if I had a breakpoint on line 199 and it never got hit, I would know there's a problem with my condition here, because that breakpoint is never getting hit. Generally, I put a breakpoint before that, see if there was something that was causing that condition to fail. Now, in the context of the debugging assignment itself, I don't believe it should skip any breakpoints. I would check to make sure that you are running the debugger itself. But I would need more context in order to actually identify what the issue is there. But yeah, usually, typically, because in the debugging assignment specifically, we tell you where to put the breakpoints. But typically, if your breakpoint isn't being hit, it's because those lines of code are never being executed, which could indicate an error before that, effectively. Yeah.
So, just so that I understand correctly, the breakpoints that show up in running the whole entire thing.
Yeah.
They should be there.
Yeah. Yeah. So a breakpoint lets you to stop your application midway, basically. Because if it's broken in the middle, it's gonna be broken at the end. Yeah, because I would need to see it. Like I said, that's going to be a more specific issue. So when you hit the breakpoint, you should see one of two of these tabs pop up. They may both pop up. One is called autos, one is called locals. Autos is something that is like the whole most of the application has access to those variables. Locals means it only exists in this local structure. And again, we'll talk more about those local structures in week 2. But generally speaking, you should just check both of those tabs if both of them are available. Now, one important thing to note is that when the breakpoint is hit, it stops at the beginning of the line. So it doesn't read the entire line. It reads up to the beginning of that line. So this breakpoint will give you information of everything that happened before this, but not necessarily anything that happens after this, right? If something is happening on this line specifically, and you want to see it, you will need to go further into your code in order to see that. And I try to write code like da-da-da, and then a second quotation mark gets deleted when I put the cursor. That you probably have the insert key pressed. So your insert on your keyboard is probably toggled on. You can find that insert key. It's usually above your backspace key. It should fix that. I mean, you can usually identify that by your cursor being like a box instead of a line, right? That's usually a pretty good indicator of that. So this button right here will step into the line of code that you are currently observing. So if we are looking at a breakpoint, right, it will step into that line and it'll run just that one line, and we can see if anything changes. If you continue hitting this, it'll continue running your application line by line. And that means that it'll kind of jump around and things like that too. So just be aware that when you're doing this, it's going to go into some like weird system file that you didn't do, that it still needs to run to do that. If something changes during the execution of your code, you will see it highlighted, usually in this pink color, right? So this means that between the last time we hit this breakpoint and now, this value has changed to this. This helps us out because A, was this value supposed to change? B, did it change to what we expected to? If it didn't, then somewhere within these two breakpoints between point A and point B, something happened that we didn't expect to do, which kind of helps us narrow down where in our code the issue is lying, right? And then if we hit continue again, this will resume normal execution of our application. So this will just keep running our application up until the next breakpoint. If you see an error similar to this, right, where it says, I can't find the debugging target whatever.exe, this is because, remember how I talked about a little bit earlier, you saw a dialog that pops up and it says, your code has errors, do you want to run it, yes or no? And you don't read that error, that message, and you say yes, because that's what you're used to, and then your code either is running an old version of your code, or you're going to see something like this. This means that you have tried to run your application, but your application currently contains errors, and your application has never been run before, right? So you've never been able to successfully run this before. It has errors right now and cannot run. and it will not run until you resolve these errors. You will run into this most likely, the first time you'll run into this is going to be your debugging assignment, because we give you the debugging assignment with errors, and it will not run until you've resolved all those, right? So keep an eye out for this. So, how do we identify errors? First of all, let me take an aside here. I said to you guys there are no books for C++ for this class, because books are not helpful for C++ in the context of this class. Basically, the C++ stuff we would cover would be in like the first few pages of the book. There is, however, one book I do recommend, and that is part of your debugging assignment. So in your debugging assignment, you will see a link to O'Reilly Books. You should have access to O'Reilly Books through your Fullsail account. And just an aside,
Excuse me.
don't quote me in saying this, but as we talked about briefly on Monday, when you graduate, you do not lose access to your email address. And I have found that if I log into this with my student email address, I can still access O'Reilly Books. So you guys may get access to O'Reilly Books after you graduate, but I'm not promising that. Anyway, you have access to O'Reilly Books through your Fullsail account. As you can see there, I am logging into O'Reilly Books with my Fullsail account. And it has pretty much every single type of informational book you would ever want. Whereas LinkedIn Learning has a bunch of nice curated videos, O'Reilly Books has a bunch of, I already did that, yeah. Yeah, it doesn't work. Okay, hold on. O'Reilly Books has a bunch of good books. So if you wanted to find a C++ book, you could potentially find it here. Again, I don't really recommend it. I gotta manually do two-factor. That was your 2 seconds to hack into my account if you had my password. I would be impressed if you had my password. I don't even have my password. It's some kind of giant randomly generated string. Anyway, this book is called Debugging by David J. 9 Indispensable Rules for Finding Even the Most Elusive Hardware and Software Problems. I highly recommend everybody read this entire book from start to finish, and I don't read books. You don't have to read it like today. If you are a good reader, by all means. But if you are not a good reader, just skim through the book and read it best you can over time. Because these 9 indispensable rules are the best way to identify any type of bug. We can look at them real quick. Yeah, I do this in full screen to get a better. We can look at them real quick. This is all of them. But number one, understand the system. If you don't know what this is supposed to do and how it's supposed to work, then you will not be able to identify a problem with it, right? If you know how it's supposed to work and how the different tools are working, how the different pieces are working, that is the first step. Number two, make it fail. If you know how it's supposed to work, do you know how to make it fail? Can you cause it to give you a predictable result that is not the one that the one that's it's supposed to do? This is like, if I remove a variable, does it break in a way that makes sense, right? That will tell you if this is working, if this is working the way that it should be working, based on how your understanding of the system. Number 3, quit thinking and look. This is, don't just stare at it, get in there and actually like take it apart, start working with it. Number 4, divide and conquer. This is break the problem up into consumable steps. Go step by step and say, okay, does this step work? No. Or yes, does this step work? Yes. Does this step work? No. Number 4, change one thing at a time. Change one thing at a time and check the plug and divide and conquer are all kind of the same idea, right? That is, make small changes and see if the changes are giving you predictable results. If they are, good. If they aren't, that's another indicator of where the problem is. Checking the plug is breaking things down into binary things, right? Which is basically just like, if I turn this on and I turn this off, does anything happen? If nothing happens when you turn something on and off, that's weird, right? Then maybe that could be indicative of a problem. Keep an audit trail. This is like, don't repeat yourself. Don't go back and repeatedly check things you did. Make sure that you understand that you keep an audit trail of what you changed and why you changed it and the result you got. That way you don't end up having to backtrack and do the same thing over and over and over. Get a fresh view, which is just basically like I talked about before. Like, if you are having difficulty understanding the problem and where it is right now, try rubber duck debugging, right? Try to talk to somebody and try to explain to them what's going on, or get up, walk away, refresh your memory, instead of just staring at it over and over and over. And then finally, if you didn't fix it, it ain't fixed. That means if you tried everything and nothing worked until eventually it just started working again, no problem, the error is still there. You just don't know what caused it. So if you didn't fix it, it ain't fixed. I don't go into way more detail in it in the actual in the book. Like I said, I highly recommend it. I recommend buying a physical copy of it just to have it. When I did my master's thesis, I did it on this in particular because it's just so good and so useful. But I'm not going to read you guys the whole book. You guys should do that on your own. Alright, so here is an example of real-world hardware debugging. This is my TV. This is the TV in my bedroom. I got it from my neighbor. He was giving it away. I said, free TV? I'm not going to say no to that. This TV is mounted on the wall. We have this cable track here, which has most of my cables in it, but they're all starting to fall apart. It also has a Chromecast. It's plugged in behind it that you can't see. Chromecast is plugged into HDMI 1 back here. One day, a Chromecast quit working. TV works, TV turns on just fine, but I can't get the Chromecast to work. Why is the Chromecast not working? So I went in and I started debugging the issue. So the first thing I did is I checked the Chromecast to see if the power indicator's on. So if the light has a light on it, you can also push a button on it to check reset it. No light. So definitely something wrong with the Chromecast. Now the Chromecast is plugged into power, and a power strip hidden behind the TV. Now the power strip's way back there. I have a real hard time reaching that power strip. The TV only has like maybe 2 to 3 inches of clearance between it and the wall. And I don't want to pull this TV off the wall. It's pretty high up there, and it's not that it's heavy, but it still would be a pain in the butt. So the easier way thing to do is to check my Steam Link. So this is a hardware little Steam machine that'll help me stream games to my TV from any computer in my house. It is also plugged into that power strip. So can I turn the Steam Link on? Does that actually work? And I identified that no, the Steam Link does not turn on. Now the TV itself is not plugged into the power strip, but the Steam Link and the Chromecast both are, which tells me there's a problem with this power strip. Either the power strip itself somehow got turned off, which I sincerely doubt, or if I check this channel, which is where the power strip plugs into the wall, I might be able to locate an issue. So I moved the media center out of the way, I checked the plug, and wouldn't you know it, power strip was not plugged into the wall. At some point somebody shifted something and it got unplugged, so when I reseated the plug, that fixed the problem. That was literally checking the plug, right? That's that binary, unplug it, unplug it, plug it back in, and it worked. If that didn't work, I would use an outlet tester to test the plug, and if the plug still didn't, if the outlet didn't work, I would replace the outlet, and if that still didn't work, then it's probably a problem with the breaker, and that's getting to be above my pay grade. So that's what I'd probably call somebody else. But again, I'm checking the failure points, right? I'm taking my understanding of the system and going piece by piece and seeing if I can figure out if everything is working the way it should. And if nothing is working, I just gotta follow that trail down the line until I identify what the problem is. That is problem solving. And that is 99% of your guys' job, whether you want to hear that or not. Again, programming is not coding. I know, it's crazy. All right, so at this point, you guys should understand the difference between a syntax error, a runtime error, and a logic error. Syntax errors, again, are red squiggly lines. These indicate issues in your code. If you don't see the red squiggly lines, you go to your build menu at the top of the screen and hit rebuild. Sometimes Visual Studio has a hard time getting there. Even if you couldn't see it before, it should pop up that panel and show you what the errors are. Number two, what a breakpoint is and how we use them to analyze a given state of our application to resolve logic errors. So again, a breakpoint is only useful if our application is able to compile. That means if it has no syntax errors. And once we get to that point, we can use breakpoints to pause our application, observe the state of our application, and make sure things are the way that we expect them to be. Between point A and point B, did anything change? Did something happen that we weren't expecting to see? If something happened that we weren't expecting to see, or something that we expected to see didn't happen, we know the problem was between point A and B, and then we just keep narrowing it down until we can figure out where the issue is. And then finally, how to step through your code to watch for changes in your data. That is that step into line, right? You can either do that by putting multiple breakpoints, or step into line to step through your code line by line in order to actually identify where an error might be. Like I said, this is going to be a loaded topic, and this is going to be something that we are going to discuss throughout the class because new structures are going to show up. There's going to be new ways to debug them. All kinds of errors, new errors are going to pop up all the time. You guys are going to come up with errors that I've never seen before, and then we're going to have to figure them out together, right? But this is something you guys are going to be learning and doing for the rest of your life. Even if you read that whole book, you will not run into errors, and you will not inherently know how to find every error, but you'll have a good tool set in order to understand how to locate one so that you can fix it. Any questions about any of this so far? All right, so it is 2:15, and we are going to take our first break. We're going to come back here at 2:30, and then we're going to start talking about numbers, all types of number things. So I'll see you guys in a little bit. Alright. Alexander, if you would like to do things that you are not typically allowed to do in PG1 in the challenges, that's perfectly okay. That is your place to be able to experiment with things like that. As long as you don't use them anywhere in the code for something that is going to be submitted for a grade, I do not care what you do in the challenges. Alright. So, now we are back over here. So today, we're going to be talking mostly about numbers and things like that. But before we get to the number stuff, we're going to do a little bit more of a explanation on variables real quick, just so we can get rid of some preconceptions. So, whenever we program anything, there's going to be something known as a style guide that we follow, right? So a style guide exists in design, it also exists in code, and that is a way that we do things to maintain consistency, right? So for example, you guys have seen that when I name my variables, std string name is equal to Doug, int number is equal to 5, I name my variables with lowercase names, right? That is a style guide. That is a pattern that I have named consistently, that I do consistently. In particular, I name my variables in what's known as camel case, which looks like this. So camel case means if we have multiple words, right? The first word begins with a lowercase and every other word begins with a capital letter. So for example, if I had like grade point average and I wanted to type out the whole thing, it would look like this. So this is camel case. Camel case is what I am going to use for variable names, and it is a very common pattern for naming your variables. Now, for methods, that is other things you'll start seeing in your lab too. These are so if we think about we'll talk about it more on Friday, but if you think about a variable as a reusable piece of data that we have defined and stored in a particular location, a method is a reusable chunk of logic that we can store and reuse multiple times. So example, we're doing the same thing over and over and over. We can take that chunk of code, send it off somewhere, and then just call that by using one line in order for us to actually just be able to reuse that. I will name my methods in this class using what's known as Pascal case. So that looks like this. Right, so Pascal case is grade point average would look like this. Right, so the first word of every single letter is capitalized. So this is consistent with the Google C# naming or design pattern or style guide, which I know we're not using C#, we're using C++, but this is what they do, and this is just the habit of what I have, and that's just what you guys will see, right? It doesn't matter what you guys do, so long as it's consistent, and usually this is going to be something that's set off by the company or the team you're working with, right? So that everybody has is on the same page. C# in particular, C++ in particular, sometimes you'll see methods like getLine, which are named in Pascal case, and sometimes you'll see some methods like getLine, like this, that are named in what we call snake case. So C++ has just been made by so many different people over so many different years that the built-in tools you're going to see different stuff for. I'm not going to do that. So I'm going to be consistent. I'm going to use Pascal case for my classes and methods. I'm going to use camel case for my variable names. Now, yeah. Yes, but no. So if at the beginning of my file, I did using namespace std, I would then not need to do std. And you'll see that in some of the videos you have. However, that is considered bad practice and you shouldn't do it. Personally, if you do it in this class, I'm not going to care. However, you will not be able to do it in PG2, so it's kind of better just to get the habit of it. Trust me, if I could get rid of all these std prefixes, I would, but nobody wants me to do that, so I can't. All right. Now, when we are naming things ourselves, there are some rules that we must follow, and that is that in C++, our available naming or variable names can have uppercase, lowercase, A through Z. They can also have digits 0 through 9. They can also contain special characters, underscores. That's it. So, grade point average, that is a valid variable name, although I wouldn't use it based on my style guide. Obviously, grade point average, that's a valid variable name, and grade point average 1, that is a valid variable name. All these are valid. You cannot start a variable with a number though. So this would not be considered valid. So you cannot do that. That's mostly it. You can't have spaces and stuff in the middle of a variable name, obviously, because that's just not going to work. Also, you will often see me when we switch them again, the methods prefix my variable names with an underscore. That is okay. So this is okay. This is a pretty common pattern. Any questions about that so far? Yes. In a variable name, the underscore is the only symbol. If you continue hitting this, it'll application line by line. Around between different structures and things like that too. Go back in, and it worked. They can also contain special character. Thinking about like in this class using what's known as Pascal case. So it looks like this, right? So Pascal case is just that. See, so uppercase, lower, yes. Here, front, guide. Grade point average. That is a valid variable name, although I wouldn't use it based on my style guide. Obviously, grade point average, that's a valid variable name. And grade point average 1, that is a valid variable name. All these are valid. You cannot start a variable with a number though. So this would not be considered valid. So you cannot do that. That's mostly it. You can't have spaces and stuff in the middle of a variable name, obviously, because that's just not going to work. Also, you will often see me when we especially when we get the methods prefix my variable names with an underscore. That is okay. So this is okay, and this is a pretty common pattern. Any questions about that so far? Yes. In a variable name, the underscore is the only symbol allowed. Most of the other symbols, especially in C++, are going to be used as some kind of operator. So this is an operator. This is $sign is an operator. That is an operator. This is an operator. That's an operator. That's an operator. Parentheses are obviously operators. So all of those can be used. So, all right. Any other questions before we move on? Cool. All right. So, numbers. So there's various different ways for us to store numbers in C++. You guys have already seen the first and most basic one, which is an integer. So int number, well, we already have one up here. Make another one. Int number is equal to 5. Integers hold whole number values. So one thing you need to know about computers is really in general, they only ever do whole number values. I already talked about this a little bit before, but char type values are basically just numbers that are being read as letters, and strings are a bunch of char type values that are being read as numbers, or as letters. So really, integers are what a computer can do really, really well. And anything other than that, we need to do something a little weird. Now, integers themselves are what's known as a primitive data type, right? So we're thinking about like, everything that we know in the world is built up of atoms and protons and neutrons and electrons and all those things, because those are the smallest unit of anything that we know. That's what your primitive data types are. Everything in your computer is pretty much going to be built up of integers and other small data types. So the other primitive data types are as follows. Number 1, bool. Bool is a Boolean type variable. It can hold one of two values, either true or false. So Boolean answer is equal to true or false. That's it, right? That's all Boolean can ever be. Number 2, a float. A float is a floating point value. This is a number that contains a decimal point. So if we say number again, and we say 5.5, we have to put an F on it. You don't have to put an F on it, but we should put an F on it. This is a floating point value. This is a float. We also have a double, which stores a higher precision floating point. Value. So this does not require the F. Again, this does not require the F either, but you should have the F. So these are our primitive data types. Well, and char. Char is considered a primitive too. So it's built in. But at the end of the day, all of these will still be numbers. So before we get to that, anybody have any questions about this? Cool. So, we already talked about letter, right, char, where we said the letter N. It would look like this. So this is camel case. Camel case is what I am going to use for now. Yeah. Guide. Obviously, grade, point average. Strings are a bunch of chart type values that are being read as numbers, as letters. So really, integers are what a computer can do really, really well. And plus plus. You guys have already seen the first and most basic one, which is an integer. So int number, well, we already have one up here. Make another one. Int number is equal to 5. Integers hold whole number values. So one thing you need to know about computers is really in general, they only ever do whole number values. I already talked about this a little bit before, but char type values are basically just numbers that are being read as letters, and strings are a bunch of char type values that are being read as numbers, or as letters. So really, integers are what a computer can do really, really well. And anything other than that, we need to do something a little weird. Now, integers themselves are what's known as a primitive data type, right? So we're thinking about everything that we know in the world is built up of atoms and protons and neutrons and electrons and all those things, because those are the smallest unit of anything that we know. That's what your primitive data types are. Everything in your computer is pretty much going to be built up of integers and other small data types. So the other primitive data types are as follows. Number one, bool. Bool is a Boolean typed variable. It can hold one of two values, either true or false. So Boolean answer is equal to true or false. That's it. Right? That's all a Boolean can ever be. Number two, a float. A float is a floating point value. This is a number that contains a decimal point. So if we say number again and we say 5.5, we have to put an F on it. You don't have to put an F on it, you should put an F on it. This is a floating point value. This is a float. We also have a double, which stores a higher precision floating point value. So this does not require the F. Again, this does not require the F either, but you should have the F. So these are our primitive data types. Well, and char. Char is considered a primitive data type, so it's built in. But at the end of the day, all of these will still be numbers. So before we get to that, anybody have any questions? So, we already talked about letter, right, char, where we said the letter A is really storing an integer value of 5, right, or 65. We already know that. Boolean is also storing an integer value. Boolean, the way it works is if it is 0, then that is considered false. But if it is any other number, that is considered true. Floating point numbers are actually using scientific notation. So this is going to be 5 plus 5 times negative 10. And you would continue doing that, right? You guys are aware of scientific notation. You know, 5 times 5, 5 times 10, 10, 10, 10. So it's doing scientific notation here, but it's only using whole number values. This is the same thing too in this particular one. This is going to be 5 plus 5, negative 10, right? So, using our Pokemon as an example, right? Everything in Pokemon has, like all the stats in Pokemon have whole number values as their thing, right? Like, the Pokemon has an attack of 65, right? Pokemon has an attack of 65. However, somebody uses Tail Swipe, right? Which is going to reduce their attack by a percentage, right? So it's going to be like minus 10% of 65, right? But how do we do that? How do we actually minus 10% from this? More than one operator matches. More than one operator equal sign matches operands. Again, Christopher, I would need to see more context of that because it sounds like there's more going on in that code. But it sounds like you don't have that. You don't have it set up in a way that's similar to this, basically. Okay. So how do we do attack times 65? Or 65 times 10%. You may think that it's something like, okay, we're going to do this times, 0.10, 0.10. But this is going to give us some issues because what's actually going to end up happening here is these are two different data types. And the computer's going to do its best to figure it out, but at the end of the day, it might not look what we expect it to. In this particular circumstance, if we had a variable that was int attack is equal to 65, and then we did attack is equal to attack times 0.1, right? Because that's would have effectively, well, actually, if we wanted to only give it, if we wanted it to be 90%, we would do that, right? 0.9. So if we wanted to reduce the attack by 10%, would look like that. What do you think is going to be stored in attack? A what? A whole number. So we go to our calculator, right? And we come here and we do 65 times 0.9. No. 65 times 0.9. Do you not know how to use calculator? 65 times 0. I'm using a programming calculator, so it can only be whole numbers.
That's funny.
65.
That's funny.
65 times 0.9 is going to equal to.
665.
God, I am just not good at this, guys. 0.9. It's going to be equal to 58.5. So, I ask you again. If I do attack times 0.9, what's going to be stored in attack?
60. 159.
58.
59.
Any other guesses? The answer is 58. It's going to drop off the decimal point, and it is going to store 58 in there, which honestly is probably fine. For Pokemon, that is probably fine. And this is actually what Pokemon does, because Pokemon's written in like C, I believe, but it might be written in assembly. And they don't have fractions or percentages at all. And when we later on in the class, we'll look at the actual damage calculation of Pokemon, and you'll see they jump through a lot of hoops to avoid having to use a fraction. But yeah, we're not going to be able to get that. But what if I actually do want to use the real value of attack as, as a percentage, right? If I want that decimal point, right? Well, one thing we could try, right, is we could say, okay, we have int attack. Comment this out real quick. We have int attack. We want to say like new attack, right? And we'll make this a float. So I'll make this a float, and then we'll say new attack is equal to attack times 0.9, right? So new attack equals 0.9. This might work. I don't have anything to run this, so I'm not going to know exactly if it would. So, but there's two circumstances that could happen depending on our compiler, right? One thing is this could equal, but I say like 58.5, or this could equal to 58.0. So one of those two things is going to happen. One of those things is what we want. One of those things is not.